students, today we'll be looking at class 9 mathematics, exercise 7.3. First question. Triangle ABC and triangle DBC are two isosceles triangles on the same base BC and vertices A and D are on the same side of BC. If AD is extended to intersect BC at P, show that triangle ABD is congruent to triangle ACD. Triangle ABP is congruent to ACP. AP bisects angle A as well as angle D, and AP is the perpendicular bisector of BC. It's given that both triangles ABC and DBC are two isosceles triangles. So we could say side AB is equal to side AC and side BD is equal to side DC. We need to show two triangles congruencies. Also, we need to show that AP bisects angle A as well as angle D, and AP is the perpendicular bisector of BC. Now, let's solve this question one by one. First, we know that side AB is equal to side AC given in the question, and side BD is equal to side DC, which is also given in the question. We can see from the diagram that AD equals AD since it's the common side in both these triangles. Thus, by SSS congruency rule, we could say that triangle ABD is congruent to triangle ACD. Hence, the first question is proved. Since these two triangles are congruent, by corresponding parts of congruent triangles, we could say that angle BAD is equal to angle DAC, which will be the first equation, and side BP is equal to side BC, that is second equation. So side BP is equal to side PC by CPCT, and angle BAD, this angle is equal to angle DAC. Now let's look at the next question. We need to prove that triangle ABP is congruent to triangle ACP. Let's see. Comparing both these triangles, we see that side AB is equal to side AC. Side AP is equal to AP. It's common in both these triangles. And we also know that angle BAD is equal to angle DAC from this first equation. Hence, we could say by SAS side angle side congruency, triangle ABP is congruent to triangle ACP. Hence, the second subdivision is also proved. Now, we already proved the congruency between triangle ABD and triangle ACD. We have also proved the congruency between triangle APB and ACP. We need to prove that AP bisects angle A as well as angle D. To prove that, let's prove the congruency between triangle DBP and triangle DCP. Let's compare these two triangles. Comparing these two triangles, we find that side BP is equal to PC by equation 2. Also, we know that side DP is equal to side DP because they are both common sides. Also, side DB is equal to side DC, which is given in the question. Thus, by SSS congruency, we could say that triangle DBP is congruent to triangle DCP. Now, since both these triangles are equal, by corresponding parts of congruent triangles, we could say that angle BPD is equal to angle CPD, which will be equation number 4. Now, from equation number 1, that is angle BAD is equal to angle DAC, we see that side AD bisects angle A into two equal halves. Also, from equation 4, we see that AD also bisects angle D into two equal halves. Thus, it is proved that AD bisects both angle A and angle D by equation 4 and equation 1. Now let's look at the last subdivision of this question. We need to prove that AP is the perpendicular bisector of BC. Let's look at the diagram. We see that angle BPD plus angle CPD forms a linear pair. Thus, we could say angle BPD plus angle CPD is equal to 180 degree. We already know that angle BPD is equal to angle CPD from equation number 4. So, let's replace angle CPD by angle BPD. So, twice angle BPD is equal to 180 degree. Thus, we could say angle BPD is equal to angle CPD, which is 90 degree. Also, we already know that side BP is equal to side PC. Hence, by these two equations, we could say that AP is the perpendicular bisector of BC. Hence, proved. Now, let's look at the next question. AD is an altitude of an isosceles triangle ABC in which AB equals AC. Let's construct an isosceles triangle ABC with AB is equal to AC. It has an altitude AD. We need to show that AD bisects BC. AD bisects BC. That is, side BD is equal to side DC needs to be proved. Also, we need to prove that AD bisects angle A, that is, angle BAD is equal to angle CAD. That these two angles are equal. Now let's see how we can solve this question. Comparing these two triangles, triangle ABD and triangle ACD, we see that side AB is equal to side AC given and angle ADB is equal to angle ADC, which is 90 degree, is also given in the question because it's an altitude. Also, in both these triangles, AD equals AD. AD is the common side in both these triangles. Thus, we could say by RHS congruency, right angled, hypotenuse and side congruency, we could say that triangle ABD is congruent to triangle ACD. Since these two triangles are congruent, by corresponding parts of congruent triangles, we could say side BD is equal to side BC and that angle BAD is equal to angle CAD. Now that we have proved that side BD is equal to side BC, thus AD bisects and PC. Similarly, since we have already proved that angle BAD equals angle CAD, hence AD bisects angle A. Hence proved. Question number 3. Two sides AB and BC and median AM of one triangle ABC are respectively equal to sides PQ and OR and median PN of triangle PQR. So we know that the side AB is equal to side PQ. Median AM is equal to median PN. and side BM is equal to side QN. Thus, side, side and side. Hence, by SS's congruency rule, we could say that the triangle ABM is congruent to triangle PQN. So, by corresponding parts of congruent triangles, we could say that angle ABM is equal to angle PQN, which will be equation number 1. We have already proved that triangle ABM is congruent to triangle PQN. So, we have proved the second subdivision. Now, let's prove the first subdivision. We need to prove that triangle ABC is congruent to triangle PQR, that these two old triangles are equal. Let's compare these two triangles. We find that in triangle ABC, we know that AM is the median. So, we could say BM is equal to MC. Also, similarly, in triangle PQR also, we know that PN is the median. Thus, we could say side QN is equal to side NR. Let this be equation 2 and equation 3. We already know that side BM is equal to side QN from the given in the question. Thus, from 2 and 3, we could say that side BC is equal to side QR, which will be equation number 4. Now, we know that from equation 1, angle ABM is equal to angle PQN. From 4, we know that side BC is equal to side QR. Also, we do know that side AB is equal to side PQ, which is given in the question. Hence, angle, side, side. By SAS congruency rule, we could say that triangle ABC is congruent to triangle PQR. Hence proved. Now let's look at the next question. BE and CF are two equal altitudes of a triangle ABC. Let's draw a triangle ABC. Let's draw an altitude BE and an altitude CF. We need to prove using RHS congruency rule that triangle ABC is an isosceles triangle. How do we do that? Let's look at the question. We know that BE equals FC. Why? Because BE and FC are two equal altitudes. Also, we know that angle BFC is equal to angle BEC, which is given in the question because they are 90 degree. Also, looking at the figure, we see that side BC is equal to side BC because both these triangles lie on the same base. Thus, by RHS congruency rule, right angle, hypotenuse and side, we could say that the triangle BFC is congruent to triangle BEC. Since these two triangles are congruent, by corresponding parts of congruent triangles, we could say that angle B is equal to angle C. By the theorem, sides opposite to equal angles, we know that sides opposite to equal angles will always be equal. Thus, side opposite to angle B, that is side AC, will be equal to side opposite to angle C, that is AB. Hence, AC is equal to AB. Since in triangle ABC, two sides are equal, we could say that triangle ABC is an isosceles triangle. Hence proved. Let's look at the last question of this exercise. Question number 5. ABC is an isosceles triangle with AB equals AC. Let's draw an isosceles triangle ABC with side AB equals AC. Draw AP perpendicular to BC to show that angle B equals angle C. We need to show that angle B is equal to angle C. Let's see how we can do this. Let's compare the triangle ABP and triangle ACP. In both these triangles, we find some equalities, that is, angle APB is equal to angle APC, which is 90 degree, because AP is the perpendicular bisector of BC. Also, since AP is the perpendicular bisector of BC, we find that it's 90 degree. Now we also know that side AB is equal to side AC because it's an isosceles triangle. And side AP equals AP because this side is both common. We could say by RHS congruency rule, right angle, hypotenuse and side, that triangle ABP is congruent to triangle APC. Now by corresponding parts of congruent triangles, since these two triangles are congruent, we could say that angle B is equal to angle C. Hence proved.